Hi there. This video forms part of a sales training course for service provider salespeople involved in finding and closing sales opportunities for managed IPVPN services. In this video, we're going to go into a deep dive into virtual private networks, or VPNs. Our objectives are to end up defining what a managed IPVPN service is, explain how VPNs have evolved over time, to describe the different types of technology that can be used for VPNs, and describe how service providers deliver VPN services over an IP network. In other videos in this little series, I'll cover the subject of managed services strategy for IPVPN and some of the key messages about selling managed services based particularly on Cisco IPVPN technology, and take you through a case study of a managed IPVPN implementation. Okay, so what do we mean by a managed IPVPN service? IPVPN stands for Virtual Private Network. Don't worry too much about the jargon. Let me quickly explain the evolution of wide area networks first. In the beginning, well, the 1970s say, if a business wanted to share information between two locations, they would lease or rent a private circuit from a service provider. For example, between a head office and a remote branch in another part of the country, or even another part of the world, so that, for example, sales figures could be communicated. Sometimes it might be helpful to have a private circuit connecting to a key supplier or major customer. As a company grows, it may set up other branch offices, and over time a network of connections would appear. This would be what we describe as a hub and spoke network. But what if information needed to be shared between some of those branches? Then it would make sense to start adding private circuits directly between some of the branch offices, creating a partial mesh network. If all the sites were interconnected, this would become a fully mesh network. The great thing about using private circuits to give this connectivity is you actually have a private and secure network. Okay, so what's wrong with this picture? Well, the thing is that every new circuit that gets added will incur ongoing rental costs, and each site will end up with more and more circuits, becoming increasingly difficult to manage. Each circuit would often be dedicated to just one type of service like voice or data, and sharing the bandwidth needed extra expensive equipment. In the 1980s, a number of new technologies appeared. X25 packet switching, frame relay and ATM cell switching systems. With these, it was possible to create a virtual private network. Adding some of this new technology meant you could set up a virtual circuit over a shared network. Now you could lease one single private circuit from the service provider, and using the switching technology, share that bandwidth. As a result, you get what appears to be a dedicated private circuit over what is really a shared circuit. And if you look at the big picture, you end up with what we describe as a virtual private network. For example, using a service provider's infrastructure, we could interconnect a head office with remote branches, forming an intranet. Using only a single circuit to each site, we could build a large virtual private network with many sites. We could add key partners to our VPN so we could share sensitive information securely. And even remote home workers or mobile workers could connect to a local point of presence and access our virtual private network. The OSI 7-layer model defines these switching devices as a layer 2 technology. It was revolutionary in dramatically reducing the costs of wide area networking. An ATM switch, for example, costing tens of thousands of dollars, could combine voice and data and even video over a shared circuit, saving so much money the payback time could be measured in weeks. However, on the downside, this technology is quite complex and difficult for customers to manage. Usually the customer would buy and manage their own equipment, needing a team of highly trained engineers to support it. If there were any office moves, or if some of the computer applications had to be relocated, it was a tedious process to reprogram all the equipment. And the more sites that were added, the more complex this network became. But all of this was in the days before TCP/IP, or just IP, the Internet Protocol, became the standard for network communications. Since IP became more popular in the 1990s, there have been some new ways of setting up and running virtual private networks. Now, two key features of a virtual private network are that it should be easy to gain access for new users in different locations, while at the same time being secure for the organisation. IT managers now had a choice. They could set up their own do-it-yourself VPN using something like SSL or Secure Sockets Layer. This is the feature you would use on your own PC when you connect to a secure internet site. It's when you see the HTTPS in the browser bar instead of HTTP. It's okay for some applications, but the security level isn't as good as other technologies, and it only works on those applications that have SSL enabled and switched on. Now, another way to set up some VPN Another way is to set up some VPN client software on each client device, like laptops and desktops. This means anyone connecting to a central service from a remote location will need special software with passwords to allow access. Once a connection is established and authorised, all the information now sent across this link, whatever application is used, will be encrypted. This is sometimes called tunnelling. It even means you could make a secure connection over the internet so that access is easy and inexpensive. But then again, you need some specialised IT skills in the company to set all this up, adding more and more to the cost. Oh, and by the way, the internet's okay for some things, but you just can't guarantee the bandwidth, so using it for voice or video or any other time-sensitive applications can be really frustrating. So now we move to 21st century technology, using MPLS or multi-protocol label switching to create VPNs running over IP protocols. This is the great opportunity for all service providers to get a foot in the door with a managed service. MPLS is implemented on most modern routers and is highly efficient at allocating bandwidth in real time to different applications. It prioritises bandwidth using QoS or quality of service, making sure, for example, that voice gets priority over email and other data traffic. Now your customers can get their own IP virtual private network from service providers like you with a whole range of other benefits. So now we've arrived at our definition of a managed IPVPN service. It's a virtual private network based on IP using MPLS technology delivered as a service to the customer. This means there are no capital costs involved for the customer, so they can manage their cash better. The customer needs no in-house expertise, so they save labour costs. Their service can be tailored to their needs and easily modified over time through a service level agreement. And all types of traffic, voice, data and video can be run over a single connection to each site, reducing the costs of dedicated private circuits. The customer simply signs up and you connect them to your closest point of presence where the VPN service can be delivered. Sometimes the customer may have their own equipment on site, but usually all the technology will be owned and operated by the service provider. And once you sell them a managed IPVPN, you can easily upsell and cross-sell a growing range of added value services, creating a pipeline of opportunities for you to close. But we'll save this for the next episode. So let's just summarise. In this episode, I've defined what a managed IPVPN service is. I've explained how VPNs have evolved over time. I've described the different types of technology that can be used to deliver a virtual private network, and described how service providers deliver VPN services over IP networks in the 21st century. So that's all for now. Goodbye from me, Mike Wilshire, and all of us here at Skills Connection. Oh, and good luck selling your managed IPVPN and other services to your customers.